All right. Guys, what is complete factoring? What is complete factoring? Well, guys, if I gave you an analogy, right? Maybe I would give you this analogy. Here's the number 20, right? Do you agree that that is factored? Yes, right? I've found things that multiply together to give me 20, haven't I? But is it completely factored? No, because sometimes after I do a step of factoring, I still have more to do, right? And in this example, what would I have more to do? The 10 can become a what? A 5 and a 2, right? Now it's completely factored, all right? And so that's kind of the analogy I want you guys to think about when you see the directions to factor completely, okay? So here's a trinomial, right? And would you agree that if you saw that on Friday when I had you guys work in groups, you would have used an AC method, right? So if we did that, I would take these two items and I would find the factors of negative 12. So the factors of negative 12, more specifically, the ones that I'm looking for are the ones that add up to be what? Negative 4, right? So I'm going to go right to the answer. Negative 6 and 2 add to be negative 4, right? So I would do what? I would now have my parentheses with my negative 6 and my positive 2. That's definitely true. And what goes in the front? 2x. Good. All right, so in that first group, okay, stop, freeze, hold it. In that first group, what do I have that I can take out? A 2, right? And if I take it out, what do I get? An x minus 3. In that second group, what do I have? And then when I take that out, what do I have? X plus 1. But how do I know that that can't be the answer? There's a reason. How can that definitely not be the answer? What are those two things? They're x's, right? What's x times x? X squared, not 2x squared. And so I know that this method did not work. And the reason that it didn't work is because the original problem had something that I could have done prior to that. And what's that thing that I could have done prior? Well, what do all three of those terms have in them? A GCF. Of what number? 2. So if I can take a GCF out, like that, I have to, right? I have to do that first. If I don't, Leonardo, if I don't, what happens? I got a problem, right? Okay, I got an answer that ain't gonna work. This technique will not work. Okay, so you always have to find a GCF first. Now, if I look at this example, right, the way that this person chose to factor is different from the method that I used. And they came up with this result. Well, let me ask you a question. Is that a smart answer to check? Well, what's 2x times x? 2x squared. What's negative 6 times 1? Negative 6. So I would suggest that it's a decent thing to check, right? And if you checked it, guess what? It would go back to the original. But here's the problem. What's in that? A GCF, right? And so if I took a GCF out of that, right? If I took a GCF out of that, I would have a different answer, wouldn't I? Okay? Same thing with the other example, okay? Same exact thing in the other example. So why are neither of these completely factored? Because 2x minus 6 had a GCF of 2. that was not factored out. Right, so in other words, if I use that initial example that I did, guys, that 10 and that 2 were there, right? And so I know that I had a problem, right? I know that that 10 could be done further. All right, so I think we already answered C, right? We actually, oh no, we didn't. Okay, so let's finish it now. So here's where we got, right? Let me take this and move this down to C. All right, so step number 1, we took out the GCF, right? Step number 1, we took out the GCF. But guys, what do you notice is in the parentheses? X squared minus 2x minus 3. And if I gave that to you on the board on Friday, what would you have done? Okay, I'm going to ask this question differently. Ready? Is that something that could be factorable? In other words, if I put this on the board for the 3-point quiz and said factor it, could you have? And what would you do? You would find the factors of -3, wouldn't you? What are the factors of -3? -3 and 1, or 3 and -1. Which are the ones that I want? -3 and 1, right? So do you guys agree that that would be the correct factored version of that? Fair to say? But Shayla, here's the thing. That wasn't the problem, was it? There was what? There was that 2. Well, guys, that 2 doesn't just disappear. It's still part of the what? G, C, F. Let me go back to my other analogy. Ready? The number 20, right? You guys agreed that we made it 10 and 2, right? Well, guys, is 2 one of the factors? Yeah, the same way that this 2 is one of the factors, right? But then what was there to do? There was to do another thing, right? And we took this 10 and we made a 5 and the 2, the same way that we created those. So when I ask you for the factors of this, what are you going to say? It's the 2, and it's the what? Those 2 things as well, right? Okay, does the analogy make sense? Okay. Okay, let's go to the next page. So, what do we have here, guys? We have problems where I give you the directions to do what? Completely factor. And again, every time you see that phrase, completely factor, you will always, always, always look for a GCF first. Okay? So if I look at A, is it possible for 4 to be the GCF? Well, it's the smallest number. Does it go into 12 and 40? Yes. Okay. There's an x squared. Can that be a GCF? No, because it's bigger than the x. Can the x be the GCF? No, because there's no x with the 40. Okay. I keep repeating these same phrases. It's starting to click, right, in terms of how to find that GCF. Okay. So I have a 4. When I divide 4 into these, what do I get? Well, 4 goes into 4x squared. Say it again. Oh, yeah, guys, I'm asking this question. 4x squared divided by 4. What happens? The 4's cancel. What's left? The x squared. All right. Then I'm taking 12x and I'm dividing it by 4, right? What happens? 4 goes into 12 3 times, leaving a 3x. And then 4 goes into 40 how many times? 10 times. 10. Okay. Just like the last example, what's left in the parentheses? Something that might be what? Factorable. Are there 2 numbers that multiply to be -10? and add to be positive 5. Oh, I'm sorry, and add to be positive 3. What are they? 5 and negative 2, right? So the factors of negative 10. So if you have to list them out, negative 10 and 1, 10 and negative 1, 5 and negative 2, negative 5 and positive 2, and the ones that add up to be the 3 are those 2, right? And so what am I left with? I have the 4. The 4 doesn't go away the same way the 2 doesn't go away in the other example, right? Bless you. Times x plus 5 and x minus 2. And so how many factors did that problem have at the end? How many factors did that problem have? It's a good question. 3 factors. The 4, which is a what? GCF. And then the what? The 2 factors that we created when we factored the trinomial, right? So 3 factors. Okay, what do we think about B? What can I do with B? Is there a GCF? What is it? Okay, so if I take out the 6, 6 goes into 6x squared, leaving 1x squared. 6 goes into 24, leaving the 4. What's in the parentheses? How many terms? 2 terms. What are those terms doing? Subtracting. And what do you notice about those terms? They're all perfect. So this is a what? This is a GCF followed by a difference of perfect squares, right? So I have the 6, which stays in front. It's still a GCF. And then I have one of the plus minus problems. The square root of x squared, the square root of 4. Okay, with C. Oh, so what did we learn right there? What could happen? I could go from a GCF to a DPS, not only a GCF to a trinomial, right? What about C? GCF? 2? I think you're right. Take out an x squared. 2 goes into 20 10 times, leaving an x. 2 goes into 50 25 times. So it's a trinomial, right? Hey, quick question, guys. Will I always go to a trinomial that is going to be factorable? No. Will I always go to a difference of perfect squares that's going to be a difference of perfect squares? No. I mean, actually, 2 terms that's always the difference of perfect squares? No, right? So this is a special case, right? These don't always happen. Do I have 2 numbers that multiply to be 25 and add to be 10? 25 and 1, no good. How else can I get 25? 5 and 5, and 5 and 5 adds to be, there you go, right? So x plus 5 and x plus 5. Again, if I asked you, how many factors did I create? The answer is 3 factors. Okay, 75, can that be the GCF? No, 3? Okay, how many times does 3 go into 75? 25 times. And how many times does 3 go into 3x squared? 3 and 3 cancel, and I'm left with 1x squared. And what do we notice? It's a GCF followed by a DPS again, right? Does the order that I write these matter? It sure does. What I mean by the order is 5 minus x the same as x minus 5? No, so like I think we're like accustomed to seeing the variable first, right? But does the variable have to be first? No, right? And so in this example, everybody said, okay, it's a DPS, so I think we all agree it's going to be that. But what I mean by does the order matter? What I mean by that is what? If the 25 is in the front, the 5 has to go in the front. If the x squared is the second term, the x has to be the second term. Okay, so please be careful with that. Good? Cross out that word guess and check. We don't do that anymore, do we? Yeah. In 21A, can 10 be our GCF? No, 10 does not go into 55 evenly. So what's the biggest number that multiplies into 10 evenly? 5. Does 5 go into 55? Does 5 go into 105? Okay, so we know that we're going to have a 5. Is there an x that's going to be a portion of our GCF? No, because there's no x in the what? 105. 5 goes into 10x squared. How many times? 2, leaving a x squared. 5 goes into 55. 11 times, leaving a x. And 5 goes into 105, 21 times. Now, guys, if I can give you a trinomial in the parentheses that's factorable, then I can give you any type of trinomial in the parentheses that's factorable, right? I can give you one that requires an AC method as well, right? So, what I want you to do you guys agree that it's probably going to be an answer that looks like that? Agreed? What I'm going to do is I'm going to sort of rewrite this off to the side, and I'm going to do this separately. So I need the factors of negative 42. Again, what's my trick? If I don't know what the factors are, I can go to the calculator, and what can I type in? Yep, if I go to the calculator, I'm going to graph negative 42 over x, right? And then I'm going to go to Control T. Right? And that's in that case where you can't remember what the factors are, or you're not confident, you're not finding the one that you're looking for, right? So I'm going to list them out. So I know I got 1 and 42. I'm going to leave signs off of these for just the time being, okay? Why is this on here? Go, what the heck? Go away. Two and 21. 3 and 12. Oh, I'm sorry, 3 and 14. Thank you. 4 and nothing. Don't work. 6 and 7. Were there any others? Did I miss any? I think that's all. Is that all of them? Yeah. Now, ignoring signs for a minute, I know one has to be positive and one has to be negative. Can we all agree with that? Okay. Which are the ones that are going to give me the 11? The 3 and the 4. Which one's going to be the positive? 14's positive and the 3 is negative, right? Okay, so I'm going to go with an x. Oh, no, I'm not. I'm going to go with 2x minus 3 and a 2x plus 14. Anything I can do with the 2x minus 3? No. Anything I can do with the 2x plus 14? Take out what does that leave? An x plus 7, right? So what does that represent? That represents the factored version of 2x squared plus 11x minus 21, right? I'm going to put that up top in my final answer, right? 2x minus 3, x plus 7. You got your pass. Just give me some look right now. And a pen, please. Oh, just grabbing something. Is that good? Perfect. That's fine. Go ahead and start B. Ciao. See you later. Hey, did we find a GCF? Well, what did everybody get for GCF? 3? Jamie, do you know what do you know? What's the matter? Did I scare you? Oh, why? You were deep in thought. Oh. Well, did you know? Sorry to interrupt, but did you know that I know for certain, like there's no question about it in my mind, that I'm going to give you guys a quiz or a test at some point, okay? And there will be somebody in this room who in this next step does this. Do you know that there will be somebody who does that, right? And do you know why? Because it's the person in the room who's kind of paying attention, but kind of not. And they decide that they heard, like they hear like maybe every other word, right? And so they've seen me like highlight this thing before. And so they just like kind of are paying attention. And so that squared goes in there. Okay. Right. How do I know that that squared doesn't go there? Because I'm not multiplying 4x squared and 4x squared, right? I'm multiplying 4x and 4x because I want an x squared, right? Yeah. When it happens, I'm going to show you it too. I won't show you who did it, but I'll show you it just to prove my point. Okay? Is there a number that goes into 4 and 20? What is it? 4. Leaves what? Leaves x plus 5 and 4x minus 1. Anything I can do with the 4x minus 1? No, right? So I have the x plus 5, and I have the 4x minus 1. And I am done. And I am done. How's that look? All right? So guys, I want you to notice something, okay? You really, at this point, have 3 ways to factor. You have GCF, you have differences of squares, and you have trinomials. And really, that's kind of like a 2-part thing, right? You either use the AC method, which we're still gonna actually spend some time just practicing that because that's a really important skill. And then the regular ones where you don't have to do that, right? So that's kind of where you're at. So on your assignment that you're going to start working on now, I'm giving you guys some time, which is cool. You have some factoring completely problems, right? Make sure that you're always doing what? Taking out a GCF first if you can. Okay? Say that again. Hang on a minute. Let me look.